How's it going, everybody? And thanks for stopping by and checking out our next video inside of the MPLS Layer 3 VPN section. In this video, we're going to continue our PE2CE routing setup with EIGRP for IPv6. We're going to do this between R15 and CSR6 like we've been doing, and then we'll do this between XRV9 and R14. Once we have the customer routes being learned by the provider edge routers inside of the VRF on both sides, on XR9 and on CSR6, then we'll go through the process of redistributing EIGRP to BGP and BGP to EIGRP, so doing the mutual redistribution, and then validate the routing accordingly to make sure everything's working the way that we need it to. So let's go ahead and dive into that config. But before we do that, just as a side note, when it comes to EIGRP with named mode EIGRP, which is what we're going to be doing, and IPv6, there actually is no network command or anything that we need to do. As long as the interfaces have been enabled for IPv6, as soon as we enable the IPv6 address family on R15 and CSR14, and then we enable the EIGRP IPv6 process on the VRF aware interfaces on the PE routers, the adjacency should come online right away. So we just have to enable the address family, and then that will allow the adjacencies to form and stuff like that. So let's go ahead and get that started and work our way through the config. Troubleshoot it as necessary if we need to. So I'm going to start on R15. I'm going to go to global config and type in router EIGRP MPLS address family IPv6 autonomous system 100. And then I'm going to type in, and that's literally all I had to type in. It's just those couple lines of config and I'm good to go. On CSR6, I'm going to go and type in router EIGRP MPLS address family IPv6 VRF C1 autonomous system 100. And then what should happen is I form an adjacency with R15 right away. And here we have R15 forms an adjacency right away. If I do show IPv6 route VRF C1, I should see the loopback address of R15 showing up as an EIGRP learned route. So that means everything was working out the way that it needs to be. I'm going to do the exact same thing on R14. I'm going to go to global config and type in router EIGRP MPLS address family IPv6 autonomous system 100. I'm going to go over to XRV9. I'm going to go ahead and log in. Go to global config, router EIGRP MPLS VRF C1 address family IPv6 and autonomous system 100. Interface is going to be gig 00002, and I'm going to go ahead and I'm going to commit that config. As soon as I do that and the commit applies, give that a second, we should have an adjacency with R14 here momentarily, and there we have it. So 14 is now up. XRV9 doesn't have logging turned on. Let's see if I can turn address family IPv6 and log neighbor changes. We'll do that just in case. I should have done that ahead of time. I forgot about that for EIGRP or for iOS XR. But if we do show route VRFC1 IPv6, we should see that right now we're learning these routes through BGP. So let me go on to R14 and do show run pipe include router and turn BGP off. Because right now we're going to be winning with BGP. So let me just turn BGP 10 off. So that'll tear the peering down, which it does. Now if I hit the up arrow, now we'll be learning the 10:1:14/64 via EIGRP, which is what I would expect to see. So now we have the VRF aware routing being seen on the PE routers. So now the next step is to do the mutual redistribution between BGP and EIGRP on the PE routers so that we can extend the information. So I'm going to go and do that on CSR6. Since I'm underneath the address family for EIGRP already, the first thing that I'm going to want to do is type in the topology base command. And then underneath here is where we do the redistribution. So redistribute, we're going to say redistribute BGP 100, and then we have to specify the metric that we're going to associate to that. So we're just going to give it some rather modest values. So we're going to say a bandwidth of 100 meg, a delay of 1 or 10 microseconds, fully reliable, no loading, and then an MTU of 1500. And then now that we have, that's redistributing BGP into EIGRP. Now we need to go to router BGP 100, address family IPv6 VRFC1, and we need to redistribute EIGRP and the autonomous system number here, and hit the enter key. So now we type in do show BGP VPN-v6 unicast all. We will see that this route is being advertised. So let's go ahead and see what it's being propagated as. So it should be advertised, and we'll see that there's a bunch of information here in terms of what's happening, which is what we want. We have the autonomous system number here, and then the 288, I believe, is going to be the value that's associated to the metric scaling or the rib scaling. That's out of scope for right now. Or maybe that's just 128. I really don't remember. But at any rate, that's what we have. We're going to go over to XRV9. Do show BGP VPN-v6 unicast. And we should see the 15 route coming across, which we do. We're going to go ahead and copy that link right there. And we should be, and specify VRFC1 and then the route again. Sorry, I tend to make that mistake. And we have the extended community values being propagated, which is what we want to see. So I'm going to go ahead and I'm underneath the address family. So I'm going to type in redistribute BGP 100, and then the route policy. We already have a route policy. We already have an RPL called RPL EIGRP. So I'm going to quote this guy and type that command in. Now if you type in do show run RPL, if you look right here with EIGRP, you'll see the same values are being mapped here. We're just using an RPL to do that. So it makes it a lot easier to do the configuration here than it does anywhere else. So we have that. So we're going to type in router BGP 100, VRFC1, address family IPv6 unicast, redistribute EIGRP, and then it says the instance name. You absolutely 100% need to specify the autonomous system. If you don't do that, then the routes won't propagate, because you don't call it based off the virtual instance name, you call it based off the autonomous system number. So we'll type in 100, and then we can specify other values if we want to, but we're not going to worry about that right now. Let's do a quick show config. And we have all this laid out right there. So then we're going to go ahead and just commit that config, and there we have it. So we're going to go back over to CSR6 and hit the do show BGP, and then we're going to grab this prefix right here, which is now available to us. We're going to hit the enter key, and we have all of the information that's being propagated. All of that looks good. So now if we go to 15 and type in do show IPv6 route, we should see 10:1:14:/64 in the routing table, which we do, and that's a great sign, because that tells me that using EIGRP IPv6 for a PE2CE routing protocol is working. So let's go ahead and do a trace route to 10:1:14:14 with a source address of 10:1:15:15. I want to make sure that it's numeric, and just enter key all the way through, and we're going to have to wait for the propagation to happen. And there we go. Okay, so the trace route is now complete and operational. So that tells me that we have end-to-end reachability and connectivity in terms of the operations. And that, ladies and gentlemen, is how you use EIGRP for IPv6 as a PE2CE routing protocol. That's it, really. Not much more to it than that. So thanks again so much for stopping by and hanging out with me in this video. And until next time, guys, take it easy.